Hello and welcome to our video about stars. In this video, we'll be exploring the fascinating world of stars, from how they form to how they die, and everything in between. So sit back, relax, and let's learn about these celestial bodies. What are stars? Stars are massive, luminous spheres of plasma that are primarily composed of hydrogen and helium, the two lightest and most abundant elements in the universe. The process that powers a star is called nuclear fusion, in which hydrogen atoms combine to form helium, releasing tremendous amounts of energy in the process. This energy radiates outwards, creating the heat and light that we see when we look up at the night sky. Stars vary in size, with some being smaller than the Earth and others being much larger than our entire solar system. The smallest stars, known as red dwarfs, can be less than 10% the mass of our Sun, while the largest stars, known as hypergiants, can be more than 100 times as massive. The temperature of a star also varies depending on its size and age, with the hottest stars reaching temperatures of tens of thousands of degrees Celsius. These stars appear blue in color, while cooler stars appear red. Our Sun, for example, is a yellow star with a surface temperature of around 5,500 degrees Celsius. Overall, stars are incredible objects that have fascinated humans for centuries. They provide us with light and heat, and their life cycles are intimately connected with the evolution of the universe as a whole. Types of stars. The most common type of star is the main sequence star, which includes stars like our Sun. These stars are in a stable state and generate energy through the process of nuclear fusion, with hydrogen atoms fusing together to form helium. They typically have a lifespan of billions of years. There are also giant stars, which are much larger than main sequence stars and can be up to 100 times as massive as our Sun. They have a much shorter lifespan, sometimes only lasting a few million years. Giant stars have depleted most of the hydrogen fuel in their cores and have begun to fuse helium and other heavier elements, leading to their massive size. Supergiants are even larger than giant stars and can be hundreds of times as massive as the Sun. They are also much brighter, and can outshine an entire galaxy. These stars have already fused helium and other heavier elements and are fusing even heavier elements, such as iron. White dwarfs are the remains of low-mass stars that have exhausted all of their nuclear fuel. They are incredibly dense, with a mass comparable to that of our Sun but squeezed into a sphere the size of the Earth. They are the final stage of evolution for low-mass stars like our Sun. The color of a star is determined by its temperature, with blue stars being the hottest and red stars being the coolest. The spectral type of a star is a way of classifying stars based on their temperature and other properties, ranging from O-type stars, the hottest, to M-type stars, the coolest. Overall, the different types of stars provide us with a way to understand the diverse range of celestial objects in our universe, from small and relatively stable main sequence stars to massive and explosive supergiants. Star formation. The process of star formation begins when a dense region within a cloud of gas and dust, known as a molecular cloud, begins to collapse under the force of gravity. As the cloud collapses, it begins to spin faster, forming a protostar at its center. The protostar continues to gather mass from the surrounding material, heating up and eventually reaching a temperature at which nuclear fusion can begin. At this point, the protostar becomes a true star and enters the main sequence phase of its life cycle. The process of star formation is complex and can take millions of years to complete. As the protostar grows, it can begin to push away the remaining gas and dust in the surrounding cloud, creating a bubble-like region known as an HII region. These regions can be seen in images of star-forming regions, such as the Orion Nebula. The final size of a star depends on the amount of material available in the cloud from which it forms. Small, low-mass stars like red dwarfs can form from smaller clouds, while larger, more massive stars require much larger clouds with more material. Overall, The process of star formation is a key driver of the evolution of galaxies and the universe as a whole. Without stars, the universe as we know it would not exist. Star death. The exact way in which a star dies depends on its mass. For low-mass stars like our Sun, the death process begins when they run out of fuel in their core. With no energy left to fight against gravity, the core begins to collapse, which heats up the outer layers of the star and causes them to expand. This phase of the star's life cycle is known as a red giant. As the outer layers expand, they become less dense, and the core of the star becomes more and more compact. Eventually, the core becomes hot and dense enough to begin fusing helium into heavier elements. This process releases energy, causing the outer layers of the star to be ejected into space in a process known as a planetary nebula. What remains of the star's core is a white dwarf. For more massive stars, the death process is much more explosive. When these stars run out of fuel in their cores, the core collapses under gravity and heats up, causing the outer layers of the star to be blown off in a massive explosion called a supernova. The intense heat and pressure generated by a supernova can cause the fusion of heavier elements, such as gold and platinum. What remains of the star after a supernova explosion depends on the mass of the original star. If the star was between 8 and 20 times the mass of our Sun, what's left of the core is a dense object known as a neutron star. If the star was more than 20 times the mass of our Sun, the core collapses further, forming a black hole. Overall, the process of star death is a crucial part of the evolution of the universe. Through their deaths, stars release heavier elements into space, which are then used to form new stars and planets. Star observation. One of the most common ways to observe stars is through telescopes. Astronomers use telescopes to observe stars in different wavelengths of light, including visible light, infrared, and ultraviolet light. Each wavelength provides different information about the star, such as its temperature, composition, and motion. Another way to observe stars is through spectroscopy. Spectroscopy is the study of the interaction between light and matter. By analyzing the spectrum of light emitted by a star, astronomers can determine its composition and temperature. This technique has been used to discover new elements and to study the chemical composition of stars. Astronomers can also observe the motion of stars through the Doppler effect. As a star moves towards or away from Earth, the wavelength of light emitted by the star is shifted. This shift can be measured and used to determine the star's velocity and direction of motion. In addition to telescopes and spectroscopy, astronomers also use space probes and satellites to study stars. For example, the Hubble Space Telescope has captured some of the most detailed images of stars and galaxies ever seen, while the Kepler Space Telescope was used to search for exoplanets orbiting other stars. Overall, the observation of stars is crucial to our understanding of the universe. By studying stars, we can learn about the composition and evolution of the universe, as well as the conditions that led to the formation of our own solar system and planet. And that's it for our video about stars. We hope you enjoyed learning about these fascinating celestial bodies. If you have any questions or comments, please leave them below. And don't forget to subscribe for more videos about the wonders of the universe. Thanks for watching.